This is Bitnar Talks, the engineer takes on construction. Episode 31. Hi, I'm Piotr Bitnar. Each day I help my clients plan and design building projects through Bitnar Limited, a consulting chartered structural engineer's practice. My biggest passion and the cornerstone on which I've built my business is finding clever solutions for construction projects. I am a chartered structural engineer and a budding software developer, so you can rest assured that I will strive to talk about the best practices and the use of new technologies in the industry. And if you're embarking on a construction project or are involved in planning, designing and building the world around us, you'll find this podcast useful. Approved Document O, Overheating. Hi guys, and welcome to Bitnar Talks, your favorite podcast on all matters of architecture, engineering and construction. It is Sunday the 20th of October 2024 and I'm here back with you with the 31st episode and information on Approved Document O, Overheating. I'm super happy to be back with you to deliver on yet another approved document. We are slowly getting to the end of the whole lot, as we do at the end of the year. I cannot wait to start changing the topics and start delivering on things perhaps more lively than the dry reading of the legislation and the guidance that follows it. Fortunately or unfortunately, the industry is full of legislation and standards, so it will be often inevitable to get back to it, but I'm looking forward to delivering on topics that are more universal. Anyway, the last episode treated on the accessibility of buildings other than dwellings. Let's get quickly through the recap and see what was covered last week. In the last episode, I talked about the first volume of the approved document, second volume of our approved document, Access to and Use of Buildings, dealing with buildings other than dwellings. Section 0 in the document brings us the overview of accessibility requirements. It tells us that this document highlights the importance of ensuring that buildings are accessible to all individuals, regardless of age, gender, or disability, by meeting functional performance criteria. It applies to both new constructions and existing buildings undergoing significant changes, with a focus on compliance with the Equity Act 2010 to eliminate physical barriers for those that use it that are external or people that actually operate the building. Section 1 deals with access to buildings. This section provides detailed requirements for creating accessible routes from site boundaries or parking areas to building entrances, ensuring they are firm, level, slip-resistant and free from hazards. Specific dimensions for pathways, ramps and other access features are outlined, with references to best practices for accessibility, such as Inclusive Mobility Guide. In Section 2, Access into Buildings, we are shown how the consideration of entrances should be met. They must be safe and easy to use for everyone, including people with disabilities, with clear signage, level thresholds and appropriate door widths. Both manual and power doors must be user-friendly and safe, and alternative accessible entrances must be available for revolving doors with clear visibility for glass doors to prevent accidents. Section 3 deals with horizontal and vertical circulations in buildings. This section focuses on ensuring smooth movement for all users, particularly wheelchair users, within non-residential buildings. It outlines guidelines for entrance halls, corridors, stairs and lifts, emphasizing space requirements, proper layout and the need for compliance with safety standards for seamless navigation within the building. In Section 4, Facilities in Buildings, you guessed it, we deal with facilities like sitting, refreshment counters, sleeping accommodations, O must be accessible to everyone, including wheelchair users. Specific guidelines ensure that wheelchair users can access public spaces, lecture halls, and sport venues without segregation, and the section covers the provision of accessible controls, switches, and communication aids like induction loops. Section 5 deals with sanitary accommodation in buildings, where sanitary facilities, including toilets and showers, must be accessible, spacious, and equipped with support rails, alarms, and easy-to-use controls. Special guidelines cover wheelchair-accessible unisex toilets, as well as ensuring that separate-sex facilities are also suitable for disabled users, with adequate space and safety features. In this episode, I will move to approved document O, overheating. So without further ado, let's dive straight into this. In this episode, I will talk about the statutory guidance contained within the approved document O, overheating. The document covers the requirements of Part O and Regulation 40B, and it is contained within 4 sections. Section 0 to 3 deals with overheating, and Section 4 covers the necessity to provide information to the building user. So let's get into the nitty-gritty of this approved document. Alright guys, starting with the text of the legislation. I will do both parts here, so the requirement O and Regulation 40B coming straight at ya. Part O, overheating. Overheating mitigation, requirement O1. Paragraph 1. Reasonable provision must be made in respect of a dwelling, institution or any other building containing one or more rooms for residential purposes, other than a room in a hotel, residences. 2a. Limit unwanted solar gains in summer. B. Provide an adequate means to remove heat from the indoor environment. And paragraph 2. In meeting the obligations in paragraph 1, A. Account must be taken of the safety of any occupant and their reasonable enjoyment of the residence, and B. Mechanical cooling may only be used where insufficient heat is capable of being removed from the indoor environment without it. And off to Regulation 40B, providing information. Information about overheating. Requirement 40B, paragraph 1. This regulation applies to building work in respect of building where Part O of Schedule 1 applies, where Part O of Schedule 1 imposes a requirement in relation to building work. And paragraph 2, the person carrying out the work must not later than 5 days after the work has been completed give sufficient information to the owner about the provision made in accordance with Part O, so that the systems in place further to Part O can be operated in such a manner as to protect against overheating. That went quickly, didn't it? This approved document is pretty straightforward. So Section O, as ever, gives us an introduction to the document. This requirement applies to new residential buildings only, so dwelling houses and flats, institutional overnight accommodation like schools, care homes, or any living accommodation for that matter, except hotels. Shared communal rooms or spaces for more than one residential unit also fall under the consideration of this requirement, as do spaces that are partially used for work. Some of these live work units may need an agreement with the building control on how to treat it, as there is no particular definition to what is considered a substantial proportion of the building, and that's how we are supposed to judge about it. So bear that in mind. In other clearly mixed-use scenarios, the requirement only applies to the residential part and its corridor, or otherwise the access route. As is the case with other approved documents, we may show competence in other ways than that suggested, but the agreement on that may need to be made before the building is executed. Some interaction with other requirements are noted here, like with Part B, where additional addition of escape windows may lead to overheating, or the amount of window opening for overheating will be higher than the purge ventilation requirements of Part F, or the additional ventilation may influence the use of combustion appliances. That's Part J. Part L, on the other hand, may work in opposition when solar gain is considered for heating gains in winter. The same may cause overheating in summer. Naturally, for controls, this should be accessible in line with Part K and M requirements, but Part O will have higher provision for the protection of falling from openings than that of Part K. The security of the doors and windows should also be considered in line with Part Q requirements. In the gist, requirement O treats on the reduction of high indoor temperature occurrences, and that should be done by limited unwanted solar gains in summer and providing adequate means of removing excess heat from the indoor environments. And it is all about the health and welfare, not necessarily the comfort of the occupants. The Secretary of State identifies two methods for achieving compliance, called Simplified Method and Dynamic Thermal Modeling. And these are being dealt with in the next two sections. In section 1, we treat about Simplified Method. A checklist is available in Appendix B that takes us through all the building control approver wants to see. It's 3 parts, with Part 1 stating the building and designer's details. Part 2 indicates site details like location and building category, chosen design overheating mitigation strategies like maximum area of glazing, maximum area of glazing in the most glazed room, shading strategy, total minimum free area, bedroom minimum free area, and designer's declarations. Then the Part 3 is for the builder and the building control body inspector to confirm that the building followed the strategy. So first, we categorize the building, where it is located and whether it has a cross ventilation or not. For the location buildings in England, the risk will be generally considered moderate, apart from the highly dense urban areas of London, where the risk is considered high. There is a map and list of postcodes within the Appendix C that we can refer ourselves to. Cross-ventilated houses or flats will be such that have openings on opposite sides, and each part of the building should be treated separately in that regard. Once we know these two parameters, we choose how we will mitigate the gain and how we will remove the excess heat. To limit the solar gain, we follow the consideration of the maximum glazing areas in the facade glazed the most, and for that we have handy tables with prescription percentages of the floor area for glazing. For the cross-ventilated units, we think between 22 and 37% of floor area of the room maximum for the most glazed room in the building, and between 11 to 18% for the maximum area of glazing of the floor area. Anyway, have a look at the tables. The units without cross-ventilation will obviously have smaller limits. In addition, the maximum glazing areas in the high-risk locations between northeast and northwest via the south should either have external shutters with ventilation options or glazing with maximum G value of 0.4 and minimum light transmittance of 0.7, or have overhangs with 50-degree altitude cutoff on due south-facing facades only. Removing the excess heat is by the means of opening the windows wide, and slightly different size of the free area of the opening will be required depending if the building is in high or low risk type of situation. The percentage is given in minimums of the room floor area and glazing area. So for bedrooms this will be 13 and 4% of floor area, and otherwise 6% to 12% of floor area, and between 55 to 95% of the glazing area. We can calculate the equivalent area, but following BS 13141 Part 1 or following Appendix D. It is generally considered that this expectation will exceed that of purge ventilation of document F. We need to mind though that buildings using distributed heat and hot water systems may have extra heat load coming from the piping, so the simplified method will not be suitable here. This leads us to section 2, which covers dynamic thermal modeling, and this methodology is suitable for all residential buildings and may lead to more flexibility, especially when the building is all airtight and with higher levels of insulation, when we want to use the particular location of the building in consideration, or when the buildings are highly shaded. The dynamic thermal modeling method should follow the methodology of CIBSE's TM59 publication, but to be limited to choices as described in this document, and report on this following the checklist as previously with simplified method. The limiting parameters are for the day used between hours 8 a.m. to 11 p.m. If the indoor temperature goes above 22 degrees Celsius, the window should start to open and reach full opening by the 26 degrees indoors, and vice versa for the nighttime between 11 p.m. to 8 a.m. The opening should be modeled as fully open when on the first floor or above, and not easily accessible, and the internal temperature exceeds 23 degrees. When the ground floor or easily accessible rooms are unoccupied, they should be modeled as open during the day if they are otherwise secured, and should be considered closed at night. An entrance door should be considered and closed at all times. The following strategies should also be considered: limited solar gain by the use of fixed shading devices like shutters, external blinds, overhangs and awnings. Consider glazing design taking in consideration its size, orientation, G-value, depth of the window reveal. Also think about building design in general with its different elements like balconies, articulations and features, as well as shading provided by other permanent buildings, structures or landscaping. Foliage and internal blinds are excluded from the consideration, but for more guidance on what to include and what is effective, take a look into BRE BR364 Solar Shading of Buildings publication. Removing excess heat is done typically by opening windows, ventilation louvers in external walls, mechanical ventilation or cooling systems. The preferred methods are naturally achieved by passive methods, and it will need to be demonstrated to the building control that such methods are insufficient before specifying the mechanical solutions. Section 3. It may be the case that for some reasons the simplified method of achieving appropriate level of heat mitigation is not possible, and these reasons can be varied. For example, we should consider noise levels at night, as these may preclude us from the use of openable windows. Generally, if the average noise is over 40 decibels over 8 hours between 11 p.m. and 7 a.m., or at least 10 times a night higher than 55 decibels in between the same hours, we will need to be a little bit more clever than just using windows for our heat dissipation strategy. When external air is not suitable for use in the strategy, we may need to ventilate and filter the air. Security should be achieved by either not providing overnight opening windows in position of easy access or protecting them with grillages, railings, louver shutters. The protection from falling tells us to protect open windows when needed. If the window can open by 100 millimeters, it can be considered a part of the strategy, but then if they open outwards, the handles cannot be further than 650 millimeters away from the inside face of the wall when the window is at its maximum opening position. Guarding heights will depend if the drop is higher than 600 millimeters or not. For the lesser drop height, we are reference to document K, but for higher drop, we need to provide guarding up to 1.1 meter height, and the guarding should not be easily climbable. For large openings, the guarding may as well be fixed or be formed of shutters with child-proof locks. We also need to consider the protection from entrapment, as is the case in document K. The 100mm sphere limit prevails. When we think about babies' heads getting stuck, but we should also think about fingers. So if there is an 8mm gap, well, then it should be at least 25mm, and it should not taper so to entrap a finger at any point, and looped cords must be fitted with child safety devices. Now going off to section 4, which covers the provision of information. It is all about giving the information to the owner of the new building so that they can use the building effectively. So what do we need to provide? Well, it is a non-technical instruction manual on how to use the overheating mitigation strategy and the maintenance requirements. So the overall overheating mitigation strategy needs to be included, the location of all elements of the mitigation strategy, instruction how to use these elements, the time of day when they use what and when in terms of seasons it should be used at, manufacturer's contact details, the location of controls and instruction for setting of controls, the location of sensors and how to recalibrate them, and cleaning and maintenance instructions. This should be included within the home user guide in the section called Staying Cool in Hot Weather. We are also reminded that the systems may be shared with other considerations like these for ventilation or conservation of fuel and power, and this should be treated on separately within the manual. So this is it, folks, the approved document O, overheating. Let's sum it up section by section. Section 0, Introduction. This section outlines the scope of the document, which applies to new residential buildings including dwelling houses, flats and institutional accommodations like care homes and schools. It addresses communal spaces and live-work units requiring agreements with building control or mixed-use situations. The section highlights interactions with other requirements such as parts B, F, J, L, K, M and Q, emphasizing the balance between safety, ventilation and overheating prevention. Section 1 deals with Simplified Method, and the Simplified Method provides a checklist in Appendix B for mitigating overheating in residential buildings. It categorizes buildings by location and ventilation type, with high-risk areas identified for special treatment. Strategies include limiting solar gain through glazing restrictions and shading, and removing excess heat via window openings. The method is straightforward but not suitable for buildings with high heat loads from distributed systems. Section 2, Dynamic Thermal Modeling. This section introduces the concept of dynamic thermal modeling, offering more flexibility, especially for airtight or well-insulated buildings. It follows the CIBSE TM59 methodology and allows for detailed consideration of the building's location and shading. Strategies focus on solar gain limitation and excess heat removal, favoring passive measures like shading and natural ventilations, with mechanical systems as a last resort. Section 3 deals with additional considerations like, in the case of Simplified Method, is it feasible? Factors such noise, unsuitable external air, security, and fall protection need to be considered. This includes using secure ventilation options, protecting open windows from falling hazard, and ensuring child safety by preventing entrapment in window mechanisms. Special attention is required for buildings in noisy or high-risk areas. Section 4 deals with provision of information for the building owner, and owners must be provided with a non-technical manual outlining the overheating mitigation strategy. This includes details on how to operate and maintain mitigation elements, timing for their use, and contact information to manufacturers. It should be part of the home user guide, covering how to stay cool during hot weather, alongside other systems for ventilation and energy conservation. In the next episode, I will move to approved document P, electrical safety. I hope you enjoyed this episode and that the considerations of the approved document O, overheating, are a bit clearer for you now. If you have any questions, reach out to me on LinkedIn or send me an email. I'm more than happy to help you out. In Bitna, we deal with planning, designing and managing of your projects, and we are always glad to facilitate a free initial consultation to steer you in the right direction. Visit www.bytnar.co.uk, that's www.bitna.co.uk, and reach out to us. Whether your question is if we can help you with your project or what should I do, we will be able to give you a piece of non-obligatory advice. At Bitna, we help our clients design and execute their dream homes or investments. If your building is falling apart, we can also help investigate the reasons behind it and to provide you with an appropriate strategy, design and specifications for the repair. Thank you again for listening. Please voice up your opinions. I'm waiting for you on LinkedIn and I want to hear from you. See you next week. Bitna designs the world around you. Toodaloo.